Now, let's look at another important application of derivatives, this time in economics. In economics, derivatives are often used to analyze cost, revenue, and profit. First, suppose C of X is the cost of producing X items. So function C of X tells us the cost when we produce X units of a product. The marginal cost, written as MC of X, is defined as C prime of X. This means the marginal cost is the derivative of the cost function. Marginal cost tells us how much the cost changes as production changes. Marginal cost estimates the change in cost when producing one more item. So, if we already produce X items, the marginal cost tells us approximately how much the cost will increase if we produce one additional unit. Next, suppose R of X is the revenue obtained from selling X items. The marginal revenue, written as MR of X, is defined as R prime of X. So the marginal revenue is the derivative of the revenue function. Marginal revenue tells us how revenue changes when one more item is sold. In other words, it estimates the additional revenue gain from selling one more unit. Now, let's define profit. If P of X is the profit obtained from selling X items, then the profit is defined as P of X equals R of X minus C of X. This makes sense because profit equals revenue minus cost. The marginal profit, written as NP of X, is defined as P prime of X. Using derivative rules, we can write P prime of X equals R prime of X minus C prime of X. So, the marginal profit tells us how profit changes when one more item is produced and sold. Now, let's work through example 4. Before we start solving it, let's first take a moment to understand what information is given and what the problem is asking us to do. The problem tells us that the number of barbecue dinners sold, which we call X, is related to the price per dinner, which we call P. By the equation, P of X equals 9 minus 0.03X. So here, X is the number of barbecue dinners sold, and P of X is the price per dinner in dollars. This means the price depends on how many dinners are sold. Now, we can also notice that as X increases, the price P of X decreases because of the minus sign. So this tells us that if more dinners are sold, the price per dinner goes down. The problem also gives the interval X is in between 0 and 300 inclusive, which means the number of dinners sold can be anywhere from 0 to 300. Next, the problem gives us the revenue function. It says that the revenue obtained from selling X barbecue dinners is R of X equals X times P of X. And since P of X equals 9 minus 0.03X, we can write R of X equals X times 9 minus 0.03X. And when we distribute the X, we get negative 0.03X squared plus 9X. So this function gives the total revenue when X dinners are sold. Now, let's look carefully at what the question is asking. The problem says, use the marginal revenue function to estimate the revenue obtained from selling the 101st barbecue dinner. Then, compare the estimate to the actual revenue obtained from selling that dinner. So there are really two things we need to do. First, we need to use the marginal revenue function to estimate the revenue from selling the 101st dinner. Second, we need to find the actual revenue from selling 101st dinner and then compare the two answers. Now, let's think about what revenue from the 101st dinner means. It means the extra revenue earned when sales increase from 100 dinners to 101 dinners. So the actual revenue from selling the 101st dinner is R of 101 minus R of 100. That is the increase in revenue when we sell one more dinner. But the problem first wants us to estimate using the marginal revenue function. Remember, the marginal revenue is the derivative of the revenue function, and it estimates how much revenue changes when one more unit is sold. So if we want the revenue from the 101st dinner, we evaluate the marginal revenue at x equals 100, because that is the point just before the 101st dinner is sold. So our plan is, first, find the marginal revenue function by differentiating the revenue function. Then, evaluate it at x equals 100. After that, compute the exact value and compare the result. Step 1. Find the marginal revenue function. We start with the revenue function, negative 0.03x squared plus 9x. To find the marginal revenue function, we take the derivative of R of x. Now differentiate term by term. The derivative of negative 0.03x squared is negative 0.06x plus the derivative of 9x is 9. So the marginal revenue function is negative 0.06x plus 9. Step 2. We use this function to estimate the revenue from the 101st dinner. Now, we use the derivative to estimate the revenue from selling the 101st dinner. Since the 101st dinner means going from 100 dinners to 101 dinners, we evaluate the marginal revenue at x equals 100. So we'll compute R prime of 100. R prime of 100 equals negative 0.06 times 100 plus 9. Negative 0.06 times 100 is negative 6, and negative 6 plus 9 is 3. So the marginal revenue estimate is 3. This means the revenue from selling the 101st barbecue dinner is estimated to be about $3. Next, we are going to find the actual revenue from selling the 101st dinner. The actual revenue from selling the 101st dinner is R of 101 minus R of 100. Let's compute each value. My revenue function is negative 0.03x squared plus 9x. To find R of 101, I substitute x equals 101. So I have negative 0.03 times 101 squared plus 9 times 101, which is 602.97. Next, I need to find R of 100. Since R of x is negative 0.03 x squared plus 9x, to find R of 100, I substitute x with 100. So I have R of 100 equals negative 0.03 times 100 squared plus 9 times 100, which is 600. Now, we take R of 101 minus R of 100. R of 101 is 602.97 and R of 100 is 600, which is $2.97. Now, let's compare the two results. Using the marginal revenue function, we estimated the revenue from the 101st dinner to be $3. The actual revenue from selling the 101st dinner is $2.97. These two values are very close, so the marginal revenue gave us a very good approximation.